How did the first humans begin to recognize not just that things happen, but that things happen because, and happen in structured relation? It may have started with nothing more than the lifting of a stone, noticing how effort turns into motion and motion into force. But somewhere in this primitive sequence of actions, lift, hold, release, was a revelation far deeper than cause and effect. There emerged the intuition that certain elements, how heavy something is, how high it is lifted, and how forcefully it strikes, do not just coexist, they define each other. They form a system, a triad. And this changes everything. Because once you see that these three properties, mass, distance, and energy, are logically inseparable, you begin to ask new kinds of questions. If these three are always connected, could they be connected differently? Could changing one in a certain way change another in an unexpected way? Could energy come from somewhere other than just height and weight? Could it be redirected, stored, recovered, or amplified? These are not just physical observations. They are structural insights, the first key to understanding how energy becomes form and how form becomes force. What we're going to explore today isn't just how early humans made sense of their surroundings, it's how they may have taken the first step toward understanding how to control energy itself, not by magic, not by mystery, but by reading the logic hidden in the simplest action, lifting an object and letting it fall. Let us imagine a scenario from the earliest stages of human thought and understanding, relying solely on direct observation and simple reasoning. Consider a human, equipped only with their intuitive and immediate perceptions, seeking to understand the nature of the physical world around them. They might pick up objects from the ground and notice fundamental things happening as they do this. To illustrate this clearly, suppose this early human selects an object that is noticeably heavy compared to other available objects. Immediately, a basic and clear observation can be made. The heaviness of the object is felt directly through the effort required to lift it. In other words, the act of lifting the object reveals the object's weight or mass, because the object resists the action of lifting. At this point, our observer might recognize intuitively that different objects have differing degrees of resistance, and this difference in resistance directly and intuitively identifies their relative mass. The next observable aspect, closely related to this experience, is that lifting the heavy object higher takes even greater effort. The higher one lifts the object, the more energy or effort one must expend. In simple terms, raising an object to a greater height requires proportionally more exertion. This establishes another intuitive relationship. The height to which the object is lifted and the effort required are directly related. Thus, our early observer learns that raising heavier objects or raising objects to greater heights always involves greater and greater expenditures of their own effort or energy. Then the observer would likely notice another fundamental action, one of immense importance. When the lifted object is released, it falls and impacts the ground with a force clearly discernible through sound, visible displacement, or sensation. This impact force is not random or arbitrary. It clearly correlates with both how heavy the object is and how high it was raised. A heavier object, when dropped from a certain height, strikes with greater force than a lighter object from the same height. Similarly, an object dropped from a higher position strikes with greater force than one dropped from a lower position. Hence, the third fundamental insight emerges. Impact force, observable directly in its consequences, depends directly on both the heaviness of the object and the height from which it is dropped. Having identified these three intuitively observable actions, lifting a heavy object, raising it to a certain height, and observing the impact force when it falls, the early human might now begin to reason about their interconnections. This reasoning would naturally guide them towards discovering fundamental relationships, each expressed through the direct and intuitive logic of observed reality. First, considering the relationship between heaviness, or mass, and height, the early human would clearly observe that heavier objects demand more effort to lift to any given height. Likewise, when the object is very light, it demands significantly less effort to lift to that same height, or allows easier lifting to greater heights. From this arises the intuitive realization that mass and height mutually condition each other. In other words, the heaviness of the object dictates how practically high one can lift it with their available effort, and conversely, the height one wishes to achieve dictates how heavy an object one can feasibly select to lift. Next, reflecting on the relationship between the height of lifting and the impact force at dropping, another obvious intuitive conclusion emerges. The observer notices clearly that the greater the height from which the object falls, the greater is the resulting impact force. Conversely, lower heights yield smaller, gentler impacts. Thus, height and impact force mutually imply each other. A greater height necessarily leads to a greater impact, while lesser height corresponds directly to a lesser impact. Finally, the relationship between heaviness, what we call mass, and impact force becomes, well, intuitive and unmistakable. Dropping a heavier object from a given height clearly results in greater impact force, whereas dropping a lighter object from the same height results in noticeably less impact force. This mutual dependence between mass and impact force naturally becomes evident to our observer. Impact force reveals the mass of the object in a directly experiential way. Greater force implies a heavier object, while weaker force implies a lighter one. From these three fundamental pairwise insights emerges a complete triadic relationship, what we might logically call a coexistent structure. Mass, raised height, and impact force cannot be fully or meaningfully explained in isolation from one another. Rather, they necessarily and intuitively coexist. The presence and magnitude of each element informs and shapes the presence and magnitude of the others. We refer to this structure as a coexistence because each element depends meaningfully and reciprocally on the others, such that none exists entirely independently or meaningfully isolated from this intuitive three-part system. The early human, having established these intuitive understandings, could now also reason about their inverse. Instead of observing only increasing magnitudes, our observer could intuitively notice what happens as these magnitudes diminish together. What if, instead of a heavy object, one selected a noticeably lighter object? Intuitively and experientially, it takes significantly less effort to lift it, even to the same height. What if, instead of raising the object to a considerable height, the human raised it only slightly above the ground? Clearly and immediately observable is that significantly less effort is expended and far less impact is observed upon release. What if the impact force is smaller, weaker, and less dramatic? It naturally follows, from intuition and direct observation, that either the object was not very heavy, or it was not raised very high, or both. Thus, our intuitive human observer directly recognizes another logical pattern, the relationship of mutual reduction. As one reduces the magnitude of any element, mass, height, or impact force, the others diminish correspondingly. From this reasoning, our intuitive observer now possesses a profound insight into how their world works, comprehensively articulated through direct observation alone. They recognize clearly that the effort or energy they expend to lift the object is not lost. Rather, it transforms directly into the observed impact upon release. Intuitively, it becomes clear that this relationship between effort expended and effect observed upon impact is perfectly balanced and symmetrical. They understand intuitively and without recourse to complex calculation or scientific equipment that precisely the amount of effort put into lifting an object to a certain height returns precisely as impact force upon its falling. Nothing is mysteriously added, and nothing vanishes. It is logically and experientially certain, as fundamental to the structure of reality as the act of lifting and dropping itself. Through this simple, logical, and direct reasoning, the early human can grasp, purely intuitively and experientially, one of the most profound insights underlying all classical physical understanding, that the observable universe of heavy objects, heights, and impacts fundamentally embodies a principle of balanced conservation. The energy put in directly equals the energy observed coming out. Every bit of their experience aligns fully and beautifully with this conclusion, making it intuitive, logically coherent, and experientially validated. Thus, starting with only a heavy object, a lifting action, and the observation of impact, Our earliest ancestors could intuitively discover the profound truth of energetic conservation and mutual dependence in the natural world around them.